Well, here's a set P of numbers symbolized by letters. Here's a set Q of numbers symbolized by very similar letters. The only difference between the two sets being that this one has the number G and this one does not. Let's consider the conditions on these two sets. We are told that A, B, C, D, E, F, and G, that's every symbol mentioned within these two sets, are distinct. That means there are no repeats, okay? There are no two letters that represent the same number. Integers. So they're clean, whole, nice counting numbers. We need to compare the quantity of the range of set P to quantity the range of set Q. Let's go ahead and define this word. For reminders, the range is the difference between your smallest, and let me make some more room, your smallest and largest number. So let us assume that we can come up with some substitutions for these sets within the rules here. Let's say that A is 1, that B is 2, that C is 3, that D is 4, 5, 6, and 7. Okay, so G is 7, F is 6, etc. Now we have to keep that rule the same here. 1, 2, 3, 4, 5, and 6. Now, the range of set P, the difference between the smallest and the largest number, is now 7 minus 1, which is 6. The range of set Q is now 6 minus 1. 6 minus 1 is 5. It would appear as if quantity A is greater, but hold on just a minute. Okay? There are a lot of different ways of assigning the numbers here. So before I conclude that this is the answer, let me back off for a second and try a slightly different combination that also obeys the rules of the problem. What if I got creative and I decided to make my list of numbers in set P and set Q not necessarily consecutive? What if I did something like A is 1, B is 3, C is 5, so it looks like I'm counting by odd numbers, until I get to G and I decide to say that G is equal to 2. That's not a problem. I'm allowed to do that. Those are all still distinct integers. Now, the rest of these, A is still 1, 3, 5, 7, 9, and 11, and now let's consider the range of set P. The range of set P is the largest number in P, which is now 11, minus the smallest number, which is 1. 11 minus 1 is 10. But the range of set Q is also 11 minus 1, which is also 10, of course. So we've created a situation where now the two quantities are equal. But both this situation and the one before operated within the rules of the problem. It cannot be both. Therefore, we must conclude that the relationship cannot be determined from the information given. This would have been a much different story if they fit the word consecutive in here. Fit the word consecutive in there, and now G is always bigger than F, which means the difference between G and A is always bigger than the difference between F and A. But that was not the case, and you have to be creative enough to try out the situations where that is not the case.